I'm Ian. I do DevRel and partnerships at Tools for Humanity, supporting the Worldcoin ecosystem. And I am going to talk about global proof of personhood, how you use World ID. So what I will go over in this workshop, I'll go over what World ID is, why Worldcoin created it, what you can do with it, and most importantly, how to integrate World ID into your project. Then I've also got a couple extra special notes at the end that are unique just to this event. So the big question that World ID answers is, how do you know who or what is a real and unique person, right? You might use CAPTCHAs online to prove that you're not a bot. AI is getting really good at solving CAPTCHAs, right? And when AI gets so good that CAPTCHAs aren't really that useful anymore, most places will then default to have you upload a photo of your passport or your driver's license or some other ID. And just a few weeks ago, the ID verification provider for Uber and Lyft got hacked, and photos of people's IDs got released and lots of personal information. So that's not a great solution either, right? So with World ID, you can think of it as this like passport, right, to prove you're a real human online, totally anonymously. We've built World ID to be private, inclusive, and robust, right? So for privacy, we want to know as little about you as possible, just that you're actually a real human. We want to make sure that as many real humans as possible get to use World ID, and we want to make sure that it actually does what it says it does, that with World ID, you know this is one real person. So when it comes to this, we looked at a lot of different approaches of how we can help solve this problem, right? Email or phone don't really work well. Super easy to get extra phone numbers, super easy to get extra emails. When it comes to doing KYC of official government IDs, while it does work fairly well for knowing, okay, yes, this is a real human, is verified by some government, the problem is that less than half of the global population has a digitally verifiable government ID. Web of Trust systems are a little more Web3 native, also can work fairly well, but they're not quite as scalable as we need them to be, right? In a Web of Trust system where you start with maybe 100 sort of pre-verified people, right? You might know them personally, or they might be well-known figures in the space. That can work well for a moderate scale, but when you scale up to all of humanity, you have to be so many sort of hops away from that initial core set. The more hops away you are, the less trusted you are inherently. And that leaves us with biometrics as really the next and only way to verify humanness that solves our needs. And when it comes to biometrics, there are lots of different biometric factors you can look at, right? Fingerprints, face scans, palm scans, those are ones that we're all pretty familiar with. But Face ID and Touch ID on iPhones can only distinguish up to about 1 in 30 million people. And those odds are great for authentication, right? I live in the US. The odds that the person who steals my phone is one of about 13 or 14 in the entire country that could unlock it with Face ID, I'm totally comfortable with those odds. That's way better than just them randomly guessing a 6-digit passcode. But we're trying to ensure that you're unique at the scale of billions, and 1 in 30 million is not going to get us there. We also looked at one of the most data-heavy pieces of biometric information, DNA, but that is impossible to do in a private way. We can't claim to not know anything about who you are if we're using DNA. And it's also really expensive to work with and invasive, and generally something we wanted to stay away from. So we settled on iris biometrics, right? That colored part of your eye around the pupil. It's got lots of entropy, so it can be used for distinguishing that you're unique at the scale of all of humanity. But it's also something that's visible. It doesn't require any sort of invasive thing, right? It's just a photo. If you don't want to have that photo taken, you can close your eyes. It inherently requires like consent and attention, whereas a face scan is something that someone could do like while you're walking down the sidewalk going past them. So that's why we settled on iris biometrics. And then when we looked at what we use to work with those biometrics, phone sensors simply don't have enough detail, right? A photo of your iris is not going to actually have a high enough resolution to get the iris code that we use to distinguish that you're unique at all of humanity. We also looked at off-the-shelf hardware. if you've heard of Clear at the airports to like fast track your way through security. We looked at hardware just like that, but that off-the-shelf hardware is very expensive, it's very heavy, it's meant to be at a fixed location, it's not portable, and it comes with a lot of trust assumptions about it, right? None of that off-the-shelf hardware is open source. So we had to settle on building custom hardware, and that was a pretty long train to get to being a hardware company, which we never wanted to do in the first place, but we did. And this is the hardware we built. This is the Worldcoin orb. The orb has been in development since early 2020, gone through lots of different revisions, making it faster, more secure, more affordable for us to build. And the orb makes sure that you're a real human. It has, I believe, over a dozen AI models running on the orb to check and make sure that you're not a cat, not a dog, not someone holding up a photo of a human, not a mannequin head, right? Making sure you're not wearing colored contact lenses to try and trick it into thinking your iris is different than it actually is. And then it takes a photo of each of your irises, and on the orb it calculates the iris code, a digital representation of the pattern of your iris. The only thing we use that iris code for is making sure that you don't get to sign up twice. The iris codes are stored in an SMPC setup, so there's no one entity that has your whole iris code, right? We are actually like pushing the boundaries of how MPC is being used in production. And once we've verified that your iris code as generated by the orb is unique, then we verify your world ID. Your world ID is a self-custodial key pair stored on your mobile phone, and verifying your world ID means that the public key goes into a Merkle tree on chain, so that when you use your world ID to prove to some application that, yes, you're a real human, only signing up or doing this specific action once, you're generating a zero-knowledge proof, proving that you control the private key to one of those public keys in that Merkle tree. We've designed World ID to be privacy first, decentralized, and open source, and the orb overall, right? So with the orb specifically, 95% of the hardware is open source. The only things that aren't open source are the security board, which handles like secure signing operations, tamper resistance, etc. Understandable why that wouldn't be open source. And then the majority of the orb software is also now open source, and we are gradually open sourcing more and more modules as we have them audited and ensure that they're safe to put out into the world. Because we want to make sure that the tech we're building is structured in such a way that it's difficult to use for any sort of nefarious purposes people might want to do. World ID has lots of different use cases that it's suitable for, right? World ID is built on Semaphore, a protocol built by PSE, funded by the Ethereum Foundation. And one of the core use cases there was around voting, right? You want to prove that you're part of a set and that you're casting a certain vote without revealing who's casting that vote. Social media obviously makes sense. We've all seen all the bots on Twitter and how paying $5 a month for a blue check mark doesn't stop bots from paying $5 a month for a blue check mark. And customer incentives are one that I find particularly interesting. Netflix used to have a free 2-week trial when you signed up with a new email, and people spun up a bunch of new emails and never ended up paying. Netflix obviously didn't like that, so they stopped their free trials. But if they were to use something like World ID, they could offer you a 2-week free trial or a 1-month free trial, and they know very strongly that you're only going to be able to get that free trial once, right? It doesn't matter what email you use. If you try to verify with the same World ID to claim that free trial again, they'll know that you've already claimed it. We've designed World ID to be super easy to integrate, using it either on the web, on mobile, or on chain. There's 2 main ways to integrate World ID: sign in with World ID and incognito actions. So we'll start with sign in with World ID. With sign in with World ID, you can use Auth0, Next.js, use our OIDC well-known file with some other library. You can custom implement your OIDC flows, on and on and on. But we'll focus on Next.js. If you want to use sign in with World ID and Next.js, this one single provider configuration is all you have to add to your configuration of Next.auth. And then you have implemented sign in with World ID. right? And we have a template repository that already has this built out, right? You don't need to try and snap a photo and type all of this into your code editor. But it's pretty simple, right? We are instructing Nextauth to use our well-known file that includes a lot of configuration of what endpoints to use, things like that. You'll put in the client ID and client secret that you'll get from the Worldcoin developer portal. And then in the profile, we include the ID, which is the nullifier hash, your unique identifier from World ID for the specific website you're logging into. And then the credential type or verification level. Is this user orb verified, or are they just device verified, right? The device verification allows you to install World App on your phone. World App checks to make sure it's running on a real phone, not a virtual machine, and that only has one World ID associated with it. So it's a much weaker sybil resistance mechanism, but still a valuable one, because you'd have to spend at least $50 or so per phone to get another device verified World ID. So that especially works well for signing with World ID when you don't want to require that a user logging into your application has to visit the orb first, for example. Then we can also talk about incognito actions. Incognito actions are sort of the native way to use World ID. With incognito actions, your application gets to know that your user is a unique human, doing an action only once, or however many times you want. You can make it 2 times or 3 times or 10 times or even unlimited times. You have that flexibility. And optionally, with a tamper-proof message that we call the signal. Right? So I'd mentioned that Semaphore, the protocol on which World ID is based, had voting in mind as one of the key use cases. So this signal is where you would put the information of who you're voting for example. Right? It's a piece of information that's an input to generating that zero-knowledge proof, as well as verifying that zero-knowledge proof. And if it doesn't match exactly between both of those, the proof won't verify. And that's how you can make sure it hasn't been tampered with. Another place that you might use that signal is if you are, say, gating an airdrop behind World ID. You might have that signal be the wallet address that should receive that airdrop. And then when you verify that proof in your smart contract on chain, you know that when they generated the proof, they wanted it to go to this address. So we'll just send it to that address rather than maybe the wallet that sent the transaction. And the flow with incognito actions is quite simple. The user will scan a QR code created by IDKit, our SDK, that's displayed in your application's front end, and that tells World App running on their phone what application and action they're verifying for. The user will generate the zero-knowledge proof on their phone and return that zero-knowledge proof to your application's front end, and then your app will verify that zero-knowledge proof. And you can either do this off-chain or on-chain. Off-chain, it is an API point on our developer portal, whereas on-chain, it's directly in the smart contract. Right? And this is that zero-knowledge proof that your app will receive. The Merkle root says, this is the root of the Merkle tree that this proof was created against. The Merkle root on Ethereum mainnet for orb verified users is updated at least once an hour because we batch insertions from new orb signups. That nullifier hash is the unique identifier of that user for this specific action. Right? So for signing with World ID, that will be anytime they sign into your app, this is that identifier. Or if you're using incognito actions, that nullifier hash can vary if you use multiple different actions within your application. Right? So if you have a vote once a week, you might use a different action for each vote. The proof is actually much longer than it looks here, and that is mathematically the zero-knowledge proof that's getting verified. And then the verification level tells you if this user is orb verified or just device verified. So let's see what using World ID incognito actions actually looks like. So if I go to the Worldcoin docs in our try it out section, you can just experiment with World ID here. So we'll go with incognito actions in the production environment. Since I have World App installed on my phone, I will say I want a minimum verification level of device verification, And we have this action with this randomly generated string here, so I haven't performed this action before. So I'll click continue with Worldcoin. And this QR code pops up. So I can either scan this with the QR scanner built into World app or just with my phone's camera, and it will take me to the app. I see information about what application I'm verifying for, a description of the action, and I tap verify with World ID. So then on my phone, that zero knowledge proof is generated, sent back to the application. This application passes its proof, or passes this proof to its backend, and its backend calls the Worldcoin developer portal to verify it off-chain, and we see that I successfully verified. So if I try to verify for this action again, I've generated another proof. It gets sent over to this application, and we can see that I've already verified for this action. Doesn't let me do it twice. So any integration of incognito actions starts with IDKit. With IDKit, right, and for this example, we're using React. IDKit is a single React widget. You give it the app ID and action as you configure them in the Worldcoin developer portal. OnSuccess and handle verify are two callback functions. Handle verify gets called as soon as it receives the proof, but still shows that pending state. OnSuccess gets called after the proof has verified successfully. Handle verify is optional because for on-chain use cases, right, you don't want to keep IDKit open, but have to, have the user send a transaction. So for on-chain, you would typically just not define handle verify. OnSuccess would store that proof, and then you would have your user submit the transaction on-chain that would include that proof to verify. And then that last parameter, the verification level, you can set the minimum verification level you want for your user. That one's also optional. It defaults to orb verification. But if you're doing an app off-chain and you want to let the device verification be allowed, you can also specify the device verification. And then the child of the widget, in this case, is just the button that opens the widget. We do also have a vanilla JavaScript package that you can use, and we also have a cloud verification template using Next.js if you're interested in that. Right? So this proof response here is what gets passed into the handle verify and OnSuccess callbacks. Right? So after we see that green check, we're not done with it. I have seen lots of projects, both at hackathons and production use cases, that get this proof back and think, great, the user's verified. But that is essentially, a piece of paper that says, yeah, I'm human, right? But you have to go check that the signature on that piece of paper is legit. So we have to verify the proof. I cannot make that clear enough. We have to verify the proof. And when it comes to verifying that proof, right, I've said we can do it off-chain and on-chain, and I'll start by describing how we do that off-chain, right? So in your backend, this again is a Next.js example. We have our app ID and action from our environment variables. We get the proof object and the signal from the front end, right? So the signal, if that was specified, you can have it be whatever you'd like. We get that in the request body to our backend. We have this verify cloud proof helper function that will call our developer portal, pass in all the necessary information, and will return a success response or an error based on whether the proof verified or not. It'll explain why the proof wasn't verified. And then, if it was successful, you should return that successful response to your front end, or you should send a response to your front end explaining why it didn't succeed. But you would also typically want to actually do something now that the user's verified. And you should do that in your back end where the user can't manipulate state like they can in the front end. So that might be that you mark the user as verified in your database. It might be that you go ahead and send them a discount code on Shopify, for example. That's an integration that we've built. But verifying these proofs is super simple. It's a single API call, and we have a helper function that abstracts that away. For on-chain verification, it's a little more complex, but again, we have a template repository that already has a very basic smart contract written for you. So in the constructor of your contract, you need to input the app ID and action ID, again, as you got them from the developer portal. But World ID here is the address of the World ID router. Right? That is the smart contract that is a proxy that will always make sure that that contract address stays consistent. And that's where you call the verify proof function, submit the proof, and get to know if the user is actually verified with World ID or not. The external nullifier, as defined here, is actually a term from Semaphore. If you're familiar with it, you'd know that that's what they use to scope the uniqueness of an action. For us, we combine the app ID and the action ID to create that external nullifier. That is so you can have multiple actions within one application. So when the user scans that QR code, they'll see the same app, they'll see a different description for that action. But in Semaphore, like every time you change that action, it's something different, and the external nullifier is just the value that defines that. And then the function to verify and execute something here, right, that's left undefined. It takes in the signal, the root of the Merkle tree, the nullifier hash, and that proof object itself, a very long hexadecimal string that's really just used for all the math. And the first thing we do is that we check a mapping that we defined earlier that should have been in the slide for the constructor. We have a mapping of nullifier hashes where when we sort of use a nullifier hash, we mark it as used. So first thing we check is, have we seen this nullifier hash before? If we have, we know the user's already done this action. We're just going to revert because we don't want them doing it twice. You could also have that map to an integer and count how many times they've done it and limit them to doing it 5 times. But once we've checked that the user hasn't done this action before, then we call the verify proof function on that World ID router. So we pass in the root, the group ID, which on-chain currently is always 1 for the orb verified group. Device verification can't be verified on-chain at this time. Then we have the signal hashed a specific way to ensure that it's within the field of the curves used for the zero-knowledge proof. The nullifier hash, that external nullifier we set in our constructor, and the proof. That verify proof function call will revert if the user is not verified or the signal is incorrect or for whatever reason it shouldn't. But if it does verify correctly, the program just continues. There's no value returned or anything like that. So the first thing you should do after that proof gets verified successfully is that you should mark that nullifier hash as used. And after that is when you should do whatever it is that you want the user to have happen after they verify with World ID. So that could also be marking their wallet address as verified if you want to reference that later. That could be going ahead and sending them tokens as part of an airdrop. Right? That is where your application defines what happens now that you know the user's verified. So we have $20,000 in prizes overall. $10,000 of that goes to the 4 best overall projects. So $4,000 to first place, $3,000 to second, $2,000 to third, and $1,000 to an honorable mention. We have $2,500 each for the most creative use case, the best governance app, and the best public goods use case. And then a $2,500 prize pool. And in that prize pool, that is for projects that don't win one of these other prizes, but make a good faith effort to integrate World ID. Right? So if you just say that you integrated World ID or have somewhere in your code a comment saying this is where we put World ID, that's not going to have you be eligible for the prize pool. But if you make an actual effort to integrate World ID, right? If you have IDKit in your front end and some commented out code in your contract saying so we couldn't get it to work, that's a good faith effort, right? And I will be at our booth all weekend. I'm probably sleeping here Saturday night because I like staying up late working with hackers, right? So it's much more about like trying to use World ID. Obviously, I want to help you get the integrations to work. That's why I'm here. But if you aren't able to get it to work correctly, you can still get some funds from that prize pool. And then, as I mentioned at the start of this, there's a couple new things that I'm excited to talk about here. The first of them is that just on Tuesday, we announced that the developer preview of WorldChain, our own OP Stack Layer 2, is now live. So if you want to apply for access to this dev preview, you can go to worldcoin.org/world-chain-preview. And this dev preview is more for protocols and existing products that want to deploy to WorldChain before general availability. But if you're interested in building on WorldChain during the hackathon, it might be able to get you access, but a lot of the protocols you'd expect to be there aren't there yet, and that's why we don't have any bounties around WorldChain so far. And then the next thing I'm really excited about, this is the first time we're publicly talking about World ID mini apps. Mini apps create a seamless integration of World ID incognito actions, sign in with World ID, or in-app payments by having your application open in a web view inside of World App. These apps can be displayed on the World App homepage. They're discoverable by our 10 million plus World App users. And getting your app in front of 6 million verified humans around the world, it's a pretty good distribution mechanism for this industry, especially. If you want to learn more about mini apps and get early access, come see us at our booth. The team member responsible for them is arriving this evening. So I won't be able to help you until later this evening, but to learn more, come chat with us. Thank you all for your time. At worldcoin.org/Brussels24, you can see a Notion page that covers a lot of what I went over here, links to our template repositories, everything like that. And you can come find me at the Worldcoin booth at almost any time through 8 or 9 a.m. on Sunday. And then after that for judging. I have to sleep a bit.